In February 1966, a steam locomotive dragged a dead machine into a scrapyard in Salford. The thing on the drawbar had the same 6 coupled wheels as the engine pulling it, the same leading bogie, the same connecting rods. But it had never burned a lump of coal in its life, and by the time it arrived, the most interesting part of it had already been cut out and taken away. This is the GT3. Where the boiler should have been, it carried a gas turbine, and it ran on aviation kerosene. A steam and a diesel engine both work in strokes, shoving a piston up and down to turn a wheel. A turbine has no strokes at all, because every stage of it is running at once, and none of them ever pauses. At the front sits a compressor, a set of angled blades spinning at enormous speed, dragging air in and packing it into a fraction of the volume. Air squeezed that hard comes out hot before a drop of fuel has ever even touched it. That hot, compressed air is forced into a burner, where kerosene sprays in continuously and lights, and the flame then stays lit for as long as the engine is running. The burning gas expands violently, and it only has one way out, so it tears through another set of blades further back, spinning them extremely fast. Here's the part that matters. The compressor doesn't run for free, because it's driven by the engine itself, and a turbine has to spin that compressor hard before it can turn anything useful at all. Whatever is left after the compressor has taken its cut is what reaches the train. You get a great deal of power out of something very small and very light, which is why the turbine had just taken over aviation. Britain had already tried this twice. 18,000 arrived from Switzerland in 1949. 18,100 was built in Manchester 2 years later, and both of them hauled expresses out of Paddington. Crews called the first one the Kerosene Castle. Both were quietly disastrous, and the reason was fuel. A piston engine only burns what you ask of it, so ease off and it eats less. A turbine has to keep driving that compressor hard, whatever you're doing, so it burns close to a constant amount of fuel the entire time it's running. Standing in a platform, coasting downhill, or even waiting at a signal, it drinks almost as much fuel as it does climbing a bank at full power. A locomotive spends most of its working life doing exactly these things, which makes the railway close to the worst possible customer a turbine could find. 18,000 was withdrawn in 1960. 18,100 went even earlier, and was rebuilt into an electric locomotive, which is a fairly brutal verdict on the machinery they took out of it. English Electric thought that the problem was solvable, and Hughes went at the fuel burn directly. He fitted a heat exchanger, taking the waste heat pouring out of the exhaust and using it to warm the incoming air, so the fuel had less work left to do. He also split the turbine work in two. A locomotive burns power just by existing, running its brakes, its heating, and its belt-driven machinery, and a low-pressure turbine turned continuously to cover all of that, while a high-pressure turbine came in as more power was called for. Both of the earlier machines had sent their power to the wheels electrically, through a generator and a set of traction motors. Hughes wanted none of that. A turbine of that output weighs a fraction of what a boiler weighs. And on a railway, that's a problem rather than a bonus, because a locomotive grips the rail using nothing but its own weight. Hughes had to put the weight back deliberately, so the GT3 was built on bespoke, heavy steel frames that carried the machinery and held the locomotive down on the track at the same time. Around them went a chassis from the previous century, and he didn't want an experimental engine sitting on an experimental locomotive. Getting the drive down to the wheels was the hard part, because the turbine turns thousands of times a minute. A gearbox took the reduction. A flexible drive fed it onto the middle axle alone, and the side rods carried it out to the other wheels, either side, exactly as they would on a conventional steam locomotive. The tender carried no coal and no water for the engine. It held kerosene, a boiler to heat the train, water for that boiler, and a toilet for the crew. Testing started at Rugby, where the locomotive ran on rollers while it was still unfinished, before going back to the Vulcan foundry to be completed. From a shed at Whitchurch in Shropshire, it learned its trade on quiet lines between Crewe and Chester, then started loaded runs down to Llandudno Junction. In May 1961, it stood at Marylebone in the Rolling Stock Exhibition, where the Duke of Edinburgh came over to take a look at it. The serious test came last, on the West Coast Main Line from Crewe over Shap to Carlisle, with OS Nook on board recording the performance. Hughes wrote afterwards that once the GT3 had left the shed on a test run, it had never failed to complete its booked workings. The crews found it comfortable and easy to handle, and in a fully enclosed cab, with no fire to tend, they could easily hold a conversation at normal volume. Enthusiasts took the brown paint and gave it the nickname, the Chocolate Zephyr. What finished the GT3 wasn't the turbine, it was the shape. In that movie-tone film, there's a shot of the GT3 being turned on the turntable at Llandudno Junction, and that shot is the whole problem in one image. Every diesel coming out of the factories by then had a cab at each end, so at journey's end, it ran around its train and set off back the way it came. The GT3 could run around, but it faced one direction, and before its next working, it had to find a turntable every single time. Fixing that meant designing a completely new locomotive, and neither English Electric nor British Railways would pay for it, as both were committed to diesel electric by this time. GT3 went back to the Vulcan foundry at the end of 1962 and was put into store. After some internal correspondence in September 1965, the turbine and the heat exchanger were taken out. That's what was left to be dragged to Salford 4 months later. The engine on the front was a BR standard Class 4. A steam locomotive with the same 6 coupled wheels and the same leading bogie as the machine behind it. GT3 was hauled to its scrapping by the thing that had been built to replace, and from a distance the two of them looked almost alike. The turbine did come back, however. In 1972, British Rail rolled out the APT-E, a tilting experimental train with a power car at each end, and inside each of those power cars sat 5 small Leyland gas turbines. It ran at 152 miles an hour between Swindon and Reading, and that's still the British record for a train which needed no overhead electrical wires. It died of the same thing, of course. Leyland gave up on turbines, fuel prices tripled after 1973, and when the advanced passenger train went into production, it went full electric. The turbine was never really beaten by the engineering. It was beaten by the fuel bill.